In Phase 1, Planning and Configuration, we create a project containing a station, set up the hardware and configure the connections. We generate a new project via the File menu, stating the storage location and the project name. We add to the project a station, in our case a Sematic 300 station. The station contains a hardware object which we open by double-clicking, starting the Hardware Configuration tool. In this tool, the hardware is configured to reflect the actual hardware structure. All available modules are contained in the hardware catalog, which can be updated through the Internet if required. Even third-party modules can be integrated into the catalog by means of manufacturer-supplied GSD files. The hardware configuration process assigns to each module a slot, a unique address, and parameters. If these are manually assigned, the Sematic Manager checks the module addresses and parameters for plausibility and consistency. The basis of all communication within a plant or machine is a configured network. The Network Configuration tool represents all configured connections graphically and allows you to create and configure new connections. This applies both for communication with the distributed I/O and for communication between the Sematic stations. In Phase 2, Implementation and Module Test, we create the symbols, develop the control program, test it for the first time module by module, and configure the visualization function. First of all, each operand used is assigned in the symbol table a comprehensible name that matches its task. This symbolic name can then be used in the program, which makes it much easier to understand. The name will also be used by the operator control and monitoring software. Furthermore, a comment can be added to each symbol to describe its task in more detail. The symbol table can be revised and updated at any time as the program evolves. The block folder contains the user program. This includes, for instance, the system data with the configuration and communication data, as well as all executable blocks containing the control program and the user data. The resulting user program is composed of the individual program blocks. You select for each block the programming language that is best suited to the task in hand. The appropriate editor is started automatically. For the module test, the S7 PLC SIM simulation software is available. It allows you to test the user program offline without having to transfer it to the real-life plant. S7 PLC SIM simulates to a certain extent the station configured in the project. This includes, for instance, loading the user program into the CPU. The simulation contains input modules at which binary signals are controlled, or digital values entered. The results can be read, for instance, at the simulated output modules. This allows you to check the correct functioning of most of the program without leaving the office. Likewise, the development environment of the operator control and monitoring system, for instance WinCC Flexible, is integrated throughout into the Sematic Manager. Like all other integrated tools, the configuration software for the visualization function is started from the Sematic Manager. It accesses the central data pool of the Sematic Manager and stores its own visualization data in that pool, so that they are available for the other tools. Phase 3, Testing and Commissioning, includes loading the program into the controller, testing it during operation, and archiving and backup of the project. After building up a connection between the programming device and the station, we load the user program into the CPU. With one click, the Sematic Manager shows us the CPU's online program. A wide range of test tools is now available for quick and comfortable commissioning, including monitoring and control of variables, forcing of variables, program status, single-step mode with stop points. These tools provided by the Sematic Manager allow you to modify the program during operation and to see immediately what impact your corrections have on it. After commissioning, but also in between to back up your data, you can compress and archive the entire project with all its programs and data. It can also be stored in the CPU in this format. Phase 4 of an automation project is operation and maintenance. Here the Sematic Manager assists you, for instance, with its teleservice tool. The teleservice option package establishes an online telephone connection with a remote plant, thus allowing you to perform remote diagnosis of that plant. In this way, you can monitor at any moment what is going on in the remote plant and even, with all due caution, influence it. Likewise, the teleservice software allows you to change the user program at any time. Summing up, we will give you once again an overview of how the Sematic Manager accompanies you throughout all the phases of an automation project. In the planning and configuration phase, you create a project and configure the hardware of the automation device, using the hardware configuration and network configuration tools. In the implementation and module test phase, you use the various programming languages and the simulation software to generate your program and run a preliminary test on it. Testing and commissioning are performed reliably and in good time using the extensive test and diagnostic functions. In the operation and maintenance phase, you can check your machine or plant at any moment over the telephone network. All this makes the Sematic Manager an individualized toolkit that provides you with optimum support in all your automation projects.